Thank you so much. I'm Francesca Borgonovi, and this is joint work with Marco Paccagnella from the OECD. The presentation is titled Testing Gains or Testing Fatigue, Accuracy Trajectories Among Low-Educated Adults in the PIAAC assessment. And probably this is the slide with the most text that you're going to see. Now, why do we focus on low proficiency adults? I think the policy relevance is that, in fact, complex systems can only be as strong as their weakest link. Nowadays, we focus on the AI engineers developing complex models. I was a kid when the Challenger exploded in 1986, and one of the images from my childhood was actually Richard Feynman, this is the physicist, who demonstrated that the Challenger exploded not because the engineers made some kind of mistake with the electrical things, but actually the O-rings, this very, very small component, was faulty in very, very cold temperatures. So complex systems can only be as strong as the weakest link, and in societies we really need to pay attention to adults with low proficiency levels. There are individual costs in terms of income, in terms of life opportunities, but also social costs in terms of potential lower growth, potential lower productivity, lower taxes, and etc. So what are some of the groups that are at risk of having low proficiency? What we do know is that individuals with low levels of educational attainment or are older tend to have lower levels of information processing skills than the general population. We heard yesterday, not all more mature adults. It really depends on how much you practice. And in terms of practice, when we approach how do we build skills, we often think about formal instruction or informal instruction, right? But the groups that need to build their skills the most are often the ones that are the least likely to participate in formal or non-formal learning. With informal learning, it's a little bit different, but again, there are huge differences in terms of the opportunities they have on the job because of occupational placement. And one of the ideas we had, well, we often treat tests as neutral events. We are checking, it's a bit like a blood test. Nothing happens. I draw your blood, I check your situation, and that's it. But what if tests are not neutral events, and in fact, individuals learn while they do a test? So our, I don't know if I would say provocative question is, do adults actually learn while they go through the PIAAC assessment? And could it be that, in fact, this learning gain is actually stronger for individuals who have low levels of proficiency? There is quite a lot of literature on the testing effects and the learning effects of testing, and so we try to build on two strands of literature: the learning effects of testing, which is primarily with school-age children or university samples, although there is a nice study that I did with a colleague from the OECD, Francesca Visati, that really looks at how in PISA, if you by chance get a test booklet that has a lot of mathematics in it, you perform better in a second test in mathematics. It seems to work. It seems that the more tests you get, the better you are later on. But we do this with adults in the context of PIAAC. And the second strand of literature is the literature on item position effects. So how do we try to identify the extent to which individuals learn during the PIAAC assessment? Well, we look at the extent to which the accuracy with which they respond to test questions actually varies as a function of the position of the question in the assessment. And the reason why we can do that is that because PIAAC is a large-scale assessment, in fact, you have different test forms. The same item can take different positions for different individuals. Okay? So what we try to do is to try and model the accuracy during the assessment and see if this is not fixed, but varies as a function of the position of the item. There is quite a lot of literature in the context of school-age children looking at decline in achievement over the course of, for example, the PISA assessment. And what generally people find is that there are negative item position effects. In other words, if an item is placed towards the end of the assessment, accuracy is generally lower given the same level of difficulty and given the same item. But what if, in fact, you learn? Then you would see positive item position effects. Your accuracy goes up. In the context of school-age children, this has been used as a measure of motivation or lack of engagement or fatigue effects and lack of endurance. But in adult populations, in fact, they haven't seen tests for a very long time. They may not actually know how this system works, right? So we do think that maybe for these individuals, actually being exposed to these kind of assessments could be a way to learn. They have greater heterogeneity of experiences, and they're not necessarily so familiar with the digital component of the PIAAC assessment. So the provocative question is, do adults actually improve over the course of PIAAC? And we build on some of the work that has been done in the context of cycle 1, where in fact we looked, well, the OECD looked at the overall population and looked at time on task in module 2 and accuracy in module 2 versus module 1. And what you do see is that the decline in the amount of time people spend on an individual item goes down much more than accuracy. What this means is that, in fact, people become more efficient given the amount of time they spend on an individual item, which to me signals they become restless, but they actually become better at solving items given the amount of time they actually spend. So it's not an indication of lack of engagement or fatigue, but rather they would rather do something else after 35 minutes, right? So we have two competing hypotheses. If there is fatigue, accuracy goes down over the course of the assessment. If, on the other hand, they learn, there are positive learning effects, accuracy goes up. Very quickly, in terms of PIAAC structure, computer-based, low stakes, untimed, adaptive design. This is important because we actually need to take into account the fact that the types of items you get is a function of how you performed in previous items, as well as your background characteristics. And we have rich timing information and response data. So very kind of out there, what are our research questions? Does accuracy in PIAAC vary as a function of item position? We think the response will be no. Spoiler alert, we think people learn, they actually don't. Is the change in accuracy as a function of item position larger or smaller for adults with low levels of educational attainment? This is our first at-risk group, if we want to use the at-risk kind of label. The second is the change in accuracy as a function of item position larger or smaller for older adults? And finally, is the change in accuracy as a function of item position different for easy or hard items? If there are hard items, well, you know, it's very difficult to learn to solve a very hard item if it's beyond your possibilities. But if it's a relatively easy item, then the small treatment of taking the PIAAC assessment may be enough to get you there, right? How do we identify people? We actually look at individuals who took literacy or numeracy as in the first part, and numeracy and literacy, we essentially do not use adaptive problem solving. We identify item position by using the PIAAC study design. In terms of variables, our dependent variable is accuracy. So we look at correct and partially correct versus everything else. We can have more complex models, but this is the base. In terms of age, our at-risk group is 55 or plus, and we look at different age categories. In terms of educational attainment, our at-risk group is below upper secondary. Item position, this is the important bit, is the percentile of the item position, and we restrict it so that the median is at the end of the first domain. Roughly speaking, you have around 50 test questions per form. This actually depends, but this is the way in which you can actually think about one question is 2 percentile difference in the terms of item position. We have average difficulty of previous items to actually account for being fatigued because of adaptivity. We have item difficulty, but in fact we use item fixed effects. We have gender and country fixed effects. To give you some sense in terms of accuracy, because people are probably more versed in terms of the scales, so or proficiency levels, on average across the samples, people get 46% of the test items right or partially right, and this actually varies as a function of age and as a function of particularly educational attainment. Now, in terms of results, what we do see is that across the entire sample, a change in position is associated with lower accuracy. Now, this is your coefficient. How to interpret this? Well, over a test session of around 50 questions in total, this means that a difference of 1 question is around 2 percentile difference in item position. So a difference of 10 questions given this coefficient means that you have a difference of 4 percentage points in terms of accuracy. This is kind of a way to quantify what you have. What happens when you look at the low educated and particularly the group of mature low educated? Well, this is actually marginally less bad. Your decline in achievement is actually less pronounced. We then looked at whether this actually differs depending on the item difficulty, whether this is a hard item or an easy item. We looked at broad levels of proficiency. The base is level 1, level 2, 3, and then 4 or 5. And what you do see is that in the full sample, essentially you have an U-shaped. For easy and hard items, the decline in achievement is less steep. It's much steeper for items that are around 2 or 3 in terms of proficiency level. When you look at what happens when focusing on older, less educated adults, essentially the U becomes more like a V. The decline is actually a little bit steeper, but in fact, effects are broadly similar, and it's the same pattern in terms of age. Now, in terms of conclusions, well, we thought people might learn during the PIAAC test. This is actually not what we find in practice. We still find that people decline in accuracy, but low proficiency adults seem to have marginally lower declines compared to the overall population. And the decline in accuracy is more pronounced for moderately easy and harder items, and least pronounced for easy and hard items. What we want to do in the future is actually look at incorporating timing information. We haven't done that up to now. One of the issues in the testing literature is that it's really important to give people feedback. In terms of PIAAC, people don't know if they actually did well or not. So the learning opportunity is limited because they may incorporate the cognitive process that is going on, but they have no clue as to whether this was right or wrong, right? So one of the possibilities is actually to think about integrating some kind of feedback in the context of the PIAAC sessions. Would this be an interesting way for individuals to engage more in the test, but also to pay back for the time they donate, in a sense, to research? And if anyone has other ideas, please shout. And to close, for those of you who come from the Anglophone sphere, there was this TV program called The Weakest Link, and I thank you very much.